Okay, so we're looking at questions from 6.5. And Austin, you had asked about number 20. Oh, okay. All right, so for number 22, I can just tell you what I have. I have AT squared minus a 49A. Is that similar to what you have? A squared x minus A minus B squared x minus A. Okay, and that's it? All right. So if we're factoring what you've got here, I'm going to pull an x minus A out of both of those. Like it's already factoring by grouping, that's kind of been started. And that leaves me with an x minus A out front, and then an A squared minus B squared. No, because this is two terms, and it's a difference of perfect squares. So what can I do with the difference of perfect squares? The square root of A squared is A. The square root of B squared is B. This then factors, the pattern here then factors into an A plus B, A minus. Now we're done. These are all degree 1. There's no more squares or cubes left in the parentheses, and that's a clue that I'm done. But you have to recognize the difference of squares, sum and difference of cubes, and then perfect square trinomials. So there are some patterns that we've talked about that you've got to maybe practice the recognition of, it sounds like, maybe. Okay. Okay. Yep, just needed one more step in order to completely factor it. Okay. Ryan, which one did you want me to do? You want to give me your 24? That's it? Okay. Okay, so there are two terms. They're either going to be squares or cubes here. If there's a further pattern, they're going to be squares or cubes. So is 81 a square or a cube? And is 16 a square or a cube? So the square root of 81, p to the fourth, would be 9p squared. The square root of 16 is 4, and then that would be q squared. So this is the difference of two squares. It factors into 9p squared plus 4q squared times 9p squared minus 4q squared. Since these are squares, right, that's not degree 1. This is a perfect square. This is also a perfect square, but this is a plus. And because this is a plus, I know that this particular factor is now done. This one is prime. It cannot be factored any further. I've got perfect squares here, but the plus tells me it's prime. However, 9 is a perfect square. P squared is also a perfect square. Then I have the difference. So I can work with the difference, 2q squared. 2q squared. Because this is the difference, I will have two different factors, 3p plus 2q and 3p minus 2q. No, but it's about the patterning for these. You've got to practice knowing when it fits the pattern and when it does not. Correct. When you have the plus between perfect squares, you're done. That's prime. It can't be factored any further. All right. What did you have for 25, Rye? Okay. Now, can you take anything out of both of these? So then I have 27x to the third plus 125y to the sixth. We have two terms. We want to look for squareds and cubes. Is 27 a square? Is it a cube? The cube root of 27 is, what's the cube root of x cubed? So this is 3x cubed. Is 125 a cube? And is y to the sixth a cube? So this is 5 times y squared cubed. This is the sum of two cubes. So now we've got a 2. And our first factor is the cube roots added together as the initial sign says. So 3x plus 5y squared. All right, now the second factor is the square of the first root. So 3x times 3x. The opposite sign. The second term is these two multiplied together. So 3x times 5y squared, or 15xy squared. The last sign here is always positive. And then I want to square the last term. So 5y squared times 5y squared is 25y to the 4th. When you do the sum or difference of cubes, the trinomial that is factored out is always prime. So I know that cannot be factored any further. Neither can the 2. When you factor the sum or the difference of two cubes, you always get a binomial and a trinomial. The trinomial is always prime. And again, it takes a little bit of practice with this in order to get that piece of information into your head. You can, yeah. I mean, you can attempt a breakdown, but your sign is always going to be wrong in the middle one. Right? We kind of talked about that the other day. That's part of the reason this is always going to be prime. Because it messes with the sign. Okay? All right. More questions on those? Nope. Which homework assignment, Summer? Oh, they just want you to multiply it back together. Yeah. Yep. So they're asking you to essentially distribute that, do the x times the x squared. Right? All right. So then let's forge ahead here. We're going to talk about 6.7 today. And we're going to look at solving factorable quadratics. All right. First of all, little vocabulary. A quadratic equation is a second-degree polynomial in one variable. Examples include x squared minus 9 is equal to 0. This is a quadratic equation. It is degree 2. It has an equal sign. There is only one variable. X squared plus 4x plus 3 is equal to 0. This is a second quadratic equation. It is degree 2. There is one variable only, and I have an equal sign. This is also a quadratic equation. It is degree 2. There is only one letter or variable being used, and it is set equal to something else. The standard form of a quadratic equation is ax squared plus bx plus c equal to 0, where a, b, and c are real numbers. Okay. Standard form is pretty straightforward. I just want to make sure we're all clear on what standard form looks like. Of the 3 examples I gave above here, only one of them is not in standard form. Which one is not in standard form? Correct, Summer. The third one would not be standard form. If I wanted to move this to standard form, what I would do is first of all get these 2 in order. Right? Decreasing order. And then the second thing I would want to do is subtract 4 from both sides to make sure it's set equal to 0. Now we're in standard form. So far, so good? All right. All right. All right. All right. So before we can continue with solving, we also need to understand something called the zero product property. We're going to use this all of the time. It's pretty straightforward, but let's make sure. If you have A times B, and that equals 0, then what has to be true? Either A has to equal 0, or it could be true that B is equal to 0, right? Or it could be that A is equal to B, and they're both equal to 0. This is known as the zero product property, and we shall use it all the time. All right, here we go. ZPP stands for zero product property, just in case you were wondering. All right, so we're going to solve this quadratic equation. Notice it's in the form ax squared plus bx plus c. And I've set it equal to 0 so that we have an equation. So the first thing we want to make sure is it in standard form? The second thing we want to do is factor it. So if I have x squared plus 7x plus 12, I need the two numbers that multiply to give 12, but add to give me 7. So what two numbers would multiply to give me 12, but add to give me 7? So I'm going to rewrite this as x squared plus 4x plus 3x plus 12 is equal to 0. I'm going to look at the first two terms and pull out an x. And I'm going to look at the second two terms and pull out a 3. That x plus 4 factor can get pulled out front, leaving me an x plus 3 equal to 0. Now that I have the factors, I can use the zero product property, or ZPP. I have here an A times a B equal to 0. So either my x plus 4 is equal to 0, or my x plus 3 has to be 0. If x plus 4 is equal to 0, then x would equal a negative 4. Or if x plus 3 is equal to 0, then my x would equal a negative 3. We are solving those mini equations to get x is equal to a negative 4 or a negative 3. You will get up to 2 solutions. If the degree here is 2, you could get as many as 2 solutions. Questions there? Nobody's asking me any questions. Okay. All right, so let's try another one. Let's solve a 2x squared plus 3x is equal to 2. Is it in standard form? Subtracting 2 from each side to make sure it gets set equal to 0. Then we want to factor it completely. Is there anything I can take out of all 3 of those terms? No. Okay. So then I want to look at, we don't have perfect squares, we don't have perfect cubes, so I want to do a times c. So I want to multiply to be a negative 4, and I want to add to be a positive 3. So what could I multiply to give me a negative 4? And when I add them, I get a positive 3. You're right. I can't hear you when your mic's on. All right, so we've got a 2x squared, then plus 4x minus x minus 2. I'm going to pull a 2x here. X plus 2 minus 1, x plus 2, x plus 2, 2x minus 1 equals 0. Now I can use the zero product property. So that I have an A times a B equals 0. So it has to be true that either x plus 2 is equal to 0 or 2x minus 1 equals 0. So x equals -2. 2x is 1. X is 1/2. How do I know if I'm right? Like, how do I know if these work? Sure, nice. You can plug those answers back in to check. So if I put a -2 into this right side here, or left side, wait, right, left side, would I get a 2? And maybe you just use your calculator to do this piece. There we go. Right, so if I clear this out, if I do 2 times a -2 squared plus 3 times a -2, look at that, I got a 2. I was supposed to get a 2. And, well, you can do the fraction button, 1/2. Oh, my second factor was 2x minus 1. So if I let 2x minus 1 equal 0, then I have to add 1 to both sides and divide both sides by 2. 1 divided by 2 is 1/2. Good? How much time I got? I think I got time for 2 more. All righty. See if we can get 2 more in today. So let's do a solve 3x times 3x minus 10 equals a -25. Just because they try to make them hard, right? Is that in standard form? No. So I'm going to do what I can to get this into standard form. That's going to be a 9x squared minus 30x is equal to a -25. Basically, all I did was distribute. And then I'm going to move that -25 over. 9x squared minus 30x plus 25 is equal to 0. Once we've got it into factored form, or once we've got it into trinomial form, then we want to look at factoring. Now, I noticed something about this guy. Do you? Yeah, this is 9x squared. If I take the square root of that, that's going to be 3x. And if I take the square root of 25, that's 5. So my first and my last are perfect squares. Is the middle term those two multiplied together and doubled? Well, what's 5 times 3x? Yeah, so that just means I'd need a minus, right? Minus 2 times 3x times 5. So because this fits the pattern, I know that this has to be a perfect square. Whoops, I can't spell. Perfect square. So that has to be a perfect square trinomial, which means this will factor into 3x minus 5 times 3x minus 5. Then I can use the zero product property, which says if A times B is equal to 0, then either 3x minus 5 is equal to 0, or the second factor, 3x minus 5 is equal to 0. Three x is 5, x is 5/3, or 3x is 5, is 5/3. So I got x is 5/3. I got the same answer twice. Is that okay? Absolutely. We said it was a perfect square, and when you have a perfect square trinomial, you are going to get the same answer. You should. That's the whole point. Like, how do you get a 25? 5 times 5. I'm multiplying the same thing. Yes, correct. The perfect square trinomial can also be done using the A times C method. It's just that recognizing the perfect square trinomial, recognizing this pattern, square root, double their multiplication, short circuits or shortcuts that whole A times C method. Yeah, and we're just in an attempt to make it slightly more efficient and faster for you. But A times C will definitely work here. All right? All right, one last one. And I just want to show you this one. I don't know that you're going to see a lot of it in your homework, but let's talk for a minute. All right, this one says 10x cubed plus x squared minus 2x. there anything I can take out of all of these? I can take an x out. That leaves me with a 10x squared. You okay, Summer? Okay. As far as I can tell, it's not quite frozen on my end, but all right. So if I factor out an x, that will leave me, if I factor out an x, oh, the original problem is 10x cubed plus x squared minus 2x equal to 0. If I factor out an x, I'm left with 10x squared plus x minus 2. Now, the 10x squared, the minus 2, if I use the AC method, I need two numbers that multiply to a negative 20, but add to a positive 1. That gives me a 10x squared plus 5x minus 4x minus 2. When I factor by grouping, I can pull out a 5x, 2x plus 1 minus 2, negative 4. Okay, so when I'm all said and done here, I have three factors. I have an x, a 2x plus 1, and a 5x minus 2. We can still use zero product property. We just need to expand it slightly. Instead of a times b, we can do a times b times c equals 0. I have three factors being multiplied together to give me 0. So either the first one is 0, so either x equals 0, or the second one is equal to 0, or the third one is equal to 0. Solving each of those mini equations, I get not just two possibilities for x, but three possibilities for x. So I have x could be a 0, a negative 1/2, or a 2/5. You can plug it back into the original equation, 10x to the third plus x squared minus 2x, to make sure you're getting 0. all of your x values should work in the equation. And if they don't, then something went wrong. You may not have kept up with negative, or you may have divided incorrectly. But if your answer doesn't work in the original equation, something happened. Okay? Yes. Ryan, do you remember when we had the squareds? We could have had up to 2 solutions. This one is cubed. See how that degree is 3 there? That tells us we could have as many as 3 solutions. So if you get 3, you have to include all 3. And just for the record, if that was an x to the 5th power, that means we could have as many as 5 solutions. But we're not going to do all those right now. We're going to concentrate on 2s, and we're going to throw in a 3 every now and again. Mm-hmm. Correct. You're taking each of those factors by themselves and setting them equal to 0. Okay? All righty. That's what I got for you to practice for today. What's today? Wednesday? Yes, this is due Friday. I need to change the date on that. Okie doke. Austin, are you all good? Did he? Okay. He said it was bad, so thank you for letting me know. Yeah, I think it's just sometimes some days. Yeah. It's not surprising that it gets overloaded at times, but right? All right, guys, thank you. Have a good night. We'll see you tomorrow.